Alright, today we're talking about 6.3 actually. I know it says section 6.2. We're doing 6.3 today. And I'm actually going to have you guys try this starter on your own, and we're going to talk about it in class. It's homework page 304 in section 6.2. That's why it says 6.2. So try this one out. We'll talk about it in class as an opener in class. But I want to talk about 6.3, which is solving trig equations involving multiple angles. And what I mean by that is we're going to be talking about like a cosine of 2 theta or 3 theta or maybe even 4 theta. It all depends. But we'll talk about it, take it step by step. So we're going to start this problem. Cosine 2 theta equals negative root 3 over 2 by knowing what we know how to do best, and that's take inverse trig functions. So we're going to take the inverse cosine. So we get 2 theta is equal to the inverse cosine of negative root 3 over 2. Now we need to figure out, hey, what quadrants is my cosine negative? So let's draw a picture. Using all students take calculus, we know that cosine is negative in both 2 and 3. And you might be thinking, hey, Mr. Feickert, inverse cosine, isn't that restricted to quadrants 1 and 2? And while I would say possibly yes to that, my bounds tell me I'm in between 0 and 360. So we need to include all 4 quadrants here. Then we need to figure out, hey, cosine is adjacent over a hypotenuse. So my x is negative 3, and I have 2, 2, 1, negative 1, which is a, well, 30-degree angle. So my reference angle, theta hat, is 30 degrees. Let's write that down. But since I'm in quadrant 2, it's 30 degrees shy of my 180, so it's 150. Notice I wrote 2 theta here. Remember, my angle is 2 theta. We'll talk about that in a depth a little bit more in just a second. And then for my second terminal side, it's 30 degrees past. So what do we end up getting? 210 degrees. 180 plus 30 is 210. Remember what I just said? 2 theta is what my angle equals because it's 2 theta up here. I haven't done anything with the 2. Now before you go ahead and start dividing everything by 2, we need to talk about something. Because I'm dealing with 2 theta and my bounds deal with theta, I need to rewrite my bounds a little bit to incorporate 2 theta. So I need to multiply everything by 2. So I still get 0 is less than 2 theta is less than, what's 360 times 2? Well, 720 degrees. What does that really entail? That just means I'm going around my circle twice. Now if I was dealing with a 3 theta, I'd multiply everything by 3. So we'd end up going around my circle 3 times. So these first 2 that I wrote, 2 theta equals 150, 2 theta equals 210, deal with going around the circle 1 time. But now I need to incorporate the second time around the circle, which is just 150. Remember, my first terminal side is 150 degrees, and then a whole nother circle around. So I also get that 2 theta is equal to 150 plus 360, so 510 degrees. And then for dealing with my second terminal side, I just keep on going. I end up getting 210 plus 360, so 570 degrees. Now I can divide everything by 2, divide by 2, divide by 2. I get that theta is equal to 75 degrees. For the second one, theta is equal to 105 degrees. And a third one, theta is equal to 225 degrees. And then theta is equal to 285 degrees. And these 4 in red are my final answer. I need to incorporate all 4. Remember, I had to go around the circle twice because I'm dealing with 2 theta. So I had to incorporate these first 2 for my first time around the circle, and then the second 2 for the second time around. So let's do this one. Sine of 3 theta equals negative 1. Well, I'm going to immediately know that, hey, I'm dealing with 3 theta, so I need to change my bounds to deal with 3 theta. So I get 0 degrees is less than 3 theta. It's less than 360 times 3. We end up getting 1080 Really, that just equates to going around the circle 3 times. So take the inverse sine here. We get 3 theta is equal to inverse sine of -1. What is that, really? Well, -1 is just, remember, this is a sine, which is the y value, so I'm just straight down here. So the first time around the circle is 270. So I get 3 theta is equal to 270 degrees. The second time around the circle, I get 270, well, that's plus one more full circle, so I get 3 theta is equal to 630. 270 plus 360 is 630. And then lastly, the third time around the circle, I get 3 theta is equal to 990, which is just one more time around the circle. So 630 plus 360. So doing this, I've incorporated all 3 times around the circle because I'm dealing with 3 theta. So I end up getting theta divided by 3 is 90 degrees. For this one, theta, divide that by 3, 210 degrees. And for this one, theta is equal to 330 degrees. And these 3 are my answers. I need to incorporate all 3 of them. Again, just to recap, I'm dealing with 3 theta, so I had to change my bounds for 3 theta, not just 1 theta. Alright, find all solutions in radians. Remember that phrasing before we even get started. All solutions means I have to add that 360 n degrees at the end of each of my answers because I'm dealing with going around every time. Not just 2 times, not just 3 times, but an infinite number of times. Well, I don't really know how to deal with this right now, but if you look on your formula sheet, you may notice, hey, this is a sine cosine plus cosine sine, where my 2x is my angle A, and my 3x is my angle B. So let's write this in terms of one single sine, and I'm going to use the sine sum identity because it's sine cosine plus cosine sine. So I get sine of A plus B, well, A is 2x, and B is 3x. And this is equal to -1 still. So I get that sine of 5x is equal to -1. So now we just have to do what we did before. Take the inverse sine of both sides. I get 5x is equal to inverse sine of -1. Well, from last slide we know that's 270 degrees. I'm going to do this in degrees and then change it into radians at the very end. Now, from here, I'm going to deal with this all solutions before I even divide by 5, and you'll see why in just a second. Because it's 270, and I'm going to incorporate going around my circle an infinite number of times, I just write down that this is equal to, 5x is equal to 270 degrees plus 360 degrees n. Remember what that 360 n degrees did. It said, hey, 270 is when I go around the first time my circle. Let n equal 1. I end up getting 270 plus 360. Well, that's just the second time around the circle. Let n be 2. That's 270 plus 720. That's 2 times around the circle. And then let n be 3. That's the 3 more circles. Let n be 4. That's 4 times circles. 4 circles more around. So it incorporates going around the circle an infinite number of times. I just let n be 1, then 2, then 3, then 4, then 5. And from here I divide everything by 5. So I end up getting x is equal to 54 degrees plus 72 n degrees. So this is my all solutions in degrees. But now I want to talk about it in terms of radians, because radians is what my problem is asking for. So if I were to rewrite this part right here as radians, I would end up getting 5x is equal to, well, 270 degrees is 3 pi over 2 plus 360 degrees is 2 pi, and I just tack on my n at the end of that. So 5x is equal to 3 pi over 2 plus 2 pi n. And now, again, I just divide everything by 5. So I end up getting that x is equal to, well, 3 pi over 2 divided by 5. We end up getting 3 pi over 10 plus 2 pi over 5. It just stays 2 pi over 5, and then I just tack my n on at the end. Remember what that n does, just to really make that concrete in our brains? That makes every timer on my circle, just by letting n be 1, then 2, then 3, then 4. It incorporates every timer on my circle an infinite number of times. Alright. Find all degree solutions, right? All degree solutions means I'm going to have to tack on that 360n at the end. Well, I can factor this. If we want to think of sine of 3 theta to be my x value, my variable, I can factor this. We can factor that into 2 sine of 3 theta, and then sine of 3 theta. That deals with my first part. My whatever goes in my second spots here in my parentheses, they have to multiply to be -1. So I'm going to have a 1 and a 1. Then when I were to FOIL this back out, I need to have a negative sine 3 theta. So that makes this one have to be negative. Again, if we were to FOIL that back out, we'd end up getting right back where we started. So I'm going to take both of them and set them equal to 0 separately, and I won't show the intermediate steps, but for the first one, I end up getting that sine of 3 theta is equal to a -1/2. And then on the second one, I end up getting sine of 3 theta equals +1. So now I want to take the inverse sine of both sides, so I end up getting that 3 theta is equal to, well, inverse sine of -1/2. Let's talk about what that is. Notice my sign is negative here, so let's draw a picture. Where is sine negative? Well, all students take, so calculus, so it's negative in both 3 and 4. And I know that the opposite is -1. My hypotenuse is 2, so I get a -√3 and a √3. What's my angle there? Well, opposite is -1, so it would be a 30-degree angle. So for this first terminal side, it's 30 degrees past 180. So my first time for my first terminal side, there we go, I end up getting that 3 theta is equal to, well, 30 degrees past 180 is 210 degrees. But to incorporate this all degree solutions, I have to add 360n degrees at the end. Then the second time, or my second terminal side, I get 3 theta is equal to, it's 30 degrees short of 360, so it's 330 degrees, plus, to incorporate all degree solutions, 360n degrees. Now I can divide both of them by 3. I end up getting that theta for this first one is equal to 70 degrees plus 120 n degrees. So that's the answer for the first part. Divide this one by 3. I get theta is equal to 110 degrees plus, divide 360 n by 3, I get 120 n degrees. So that deals with my first chunk, my first parenthesis. Sine 3 theta equals -1/2. I get those two answers. Now let's deal with the second part. Sine of 3 theta equals 1. Well, 1, and we're dealing with sine, so where's the y value? 1, well, just straight up at 90 degrees. So I get that 3 theta, well, let's put it in purple as well. 3 theta is equal to the inverse sine of 1, well, we said that's 90 degrees, plus 360n. Again, that is all degree solutions. Now I just divide everything by 3. I get theta is equal to 30 degrees plus 120n degrees. So for this one, I end up getting 3 answers. 2 for my first parenthesis, 1 for my second parenthesis. Again, just to recap, that finding all degree solutions just means before I divide by whatever numbers tacked onto my theta, I have to add 360n degrees, and then divide by 3, or whatever number is tacked onto my theta. So go ahead and write your summary. Any questions you might have? Go ahead and take a look at the assignment here for tomorrow.